last one. We're almost out of this lesson. Actually, I've kind of enjoyed this one. Hopefully you have too. Now, we're talking about graphing, using a graph that represents, in this case, bacterial population Y after X days. Really, all that means is how many bacteria are there after however much time has passed. So in this case, we're talking about days, and that's going to be very important because this is now a value of time. And we're going to need to use that as our base. But first, we need to know what let's color coordinate a little bit that we've done before. A, B, and X. Okay, X in this case is going to be time. So color coordinate again. T for time. There we go. Now I'm on page or on par. All right. So the first thing we have to ask ourselves, what's A? Well, A is going to be our initial amount at 0. Oh. Well, I always think I'd select highlighter and I don't. So here's A because that's when X is equal to 0, or our function first starts. So here we get A is equal to 3. So now we need to worry about what is B. Well, B is what we're multiplying to go from one term of Y to the next. So we have to ask ourselves, how do we go from 3 to 12 using multiplication? Well, that's multiplying by 4. Now, how do I go from 12 to 48? I multiply by 4. How do I go from 48 to 192? I multiply by 4. And as long as I'm multiplying by the same amount, that means I have a constant rate of change, and that means that B is going to be equal to whatever I've been constantly multiplying by. So all of these 4s represent the same base that's going to a power. Now here, it says we want to find in terms of time. Okay, so we have all of these points that kind of tell us, but what we don't know is the last day we have on record is the 4th day. What we don't know is 5 days. So we could sit here and look at 1 day, 2 days, 3 days, 4 days, but we don't know, number one, what's happening. We don't know what's happening in half a day because it says 12 hours, and we don't know exactly where we're at, according to this graph, at 5 days. So it's asking us to solve that using 3 times the base, I know the base, 4, to the, in this case, the first case, we're going to want to use 1/2. And that's because this represents 1/2 day, or 12 out of 24 hours. And since we're doing this in terms of days, I need to be half a day, and that tells me 12 hours. Okay, so now that it's 1/2, really this just means 3 times the square root of 4, and 3 times the square root of 4 is the same thing as 3 times 2, and 3 times 2 is 6. So at 12 hours, we have 6 bacteria. Okay, we've solved the first question. At 12 hours, we have 6 bacteria. What about at, let's say, 5? That's the next thing it wants us to go ahead and solve. So let's do it. At 5 days, that means we have 3 times 4. So this hasn't changed, but the exponent does. Now we have 5 days. So it's the full 5. Well, that is going to be 1,024. So if you take 4 to the 5th, you're going to get 1,024. So that's the same thing as 3 times 1,024. And 3 times 1,024 is going to be 3,072. So at 5 days, we have, 72. Why in the world did I write 5? No idea. So 3,072 bacteria at 5 days, 6 bacteria at half a day, all because we found out that A, the initial point, was 3 when x was 0, y was 3, or when the input was 0, 0 times passed, there were 3 bacteria. And B was the base. That's how much we were multiplying each output by to get the next output. T was found in time for days. So we took the 12, cut it in half. That became our exponent. Otherwise, when we found out 5 days, time was 5.